Alright guys, so now I want to talk about a really easy topic that has to do with electronegativity, and that is solubility. So I went ahead and took the luxury of pre-drawing this little diagram for you. It's very scientific, and I thought that it would help you guys understand the rule of solubility, which is just that, like dissolves like. Alright, so you might have heard this in lab before, and all it means is this has to do with polarity. Okay, so remember that we learned how to figure out if molecules had a net dipole. That's all there is to it. We're going to figure out, okay, what we're dissolving, is it going into something that has the same polarity as itself? So this is, a very common scene from Friday night. Maybe this was a few nights ago for you. You're pouring a bottle, and you're pouring it into a cup of water, and you've got your ethanol little molecules spilling out, and they go into the water molecules, which are right down here. And you're not thinking for a second that they're going to split apart and you're going to have like alcohol on the top and water on the bottom. That would be really weird. In fact, what happens is that they just mix together and you can't even tell the difference, except you can tell the difference the next morning. You know that obviously you weren't just drinking water. So that has to do with the fact that both have the same polarity or similar polarity. Think about it. Water, let's just expand this a little bit. Water has a net dipole, right? We said that the net dipole was pretty strong. Well, in the same way, ethanol also has a net dipole, okay? So in this case, I kind of drew it so that the net dipole would face the other direction, but it doesn't matter. It doesn't really matter what direction it's facing because obviously I could rotate that alcohol. The important thing is that they both have a strong net dipole. Since they're both polar, they're going to dissolve into each other, okay? So that's the entire concept between like dissolves like.